Hey there, I'm srcmake and welcome to the video on the algorithm trick about encoding matrix positions into a single value. So in this video, we are going to look at what matrices are, and we're going to look at what types of algorithms open up to us once we learn this trick. We've got a section on encoding matrix positions, and we've got a couple of formulas here, and we've got a diagram that is also open up in Microsoft Paint because we are going to be going through a very particular example to know that we know how the encoding and decoding works and that we can do it ourselves. We've got another section on code just to make sure that we can translate all of these formulas into code, in particular these two functions, and we are going to be going over that to make sure that we can do it in any interviews or algorithm competitions. And you probably want to bookmark this page so that you can just come back and copy and paste this in the future and you don't even have to think about it after this video. So this webpage will be below the video. There'll be a link. You click it, get to this webpage, bookmark it, you're good to go. And while you're down there, hit the subscribe button for this YouTube channel. Thanks. So encoding matrix positions into a single value. Matrices are simply two-dimensional arrays, and to access an element in a matrix, you would look at that element's row position and column position. And in the code, it would be something like looking at the matrix variable and doing something like I and j inside of brackets. Now, matrices come up all the time. It's basically a basic data structure like arrays are. But representing elements with two distinct keys, the position I and j, are really tricky because then it is hard to work with certain algorithms because you have those two distinct keys to represent that one element. And so if we were able to represent that element without I and j, but just with one single value, certain things would open up to us. For example, we would be able to represent that 2D matrix as a 1D array, which is super useful and opens up even more algorithms to us. Or possibly, we would be able to create a hash map where the key in that hash map is the position in the matrix. And you can't normally do this because it's really hard to hash a pure I and j. Those two things, hashing two things, not easy at all. But to hash a single value is super easy, and it makes lookup times order 1, which is really good in algorithms. And so being able to do that is really useful. And so the way we could do that, and I'll go to Paint for this section, is we could look at the array, and for each cell of the array, we would just represent it with a single value like this. And so reading it like a book, each one of these cells is represented by 0, 1, 2, 3, 4, 5, 6, 7. Basically read it off. Each cell is its own number. And yeah, it just increments like that. And so if we look at these formulas, which are the most important thing to understand, to encode a position ij into a value h, we would multiply I by the number of columns and add j. And then once you have that encoded value, if you wanted to decode it back into ij, what you could do is you could divide the encoded value by the number of columns to get I, or you could divide the encoded, you could modulus the encoded value h by the number of columns to get j. And so let's go through one particular example right now. Let's say we are looking at this element in the array right here. The value is 7, the I is equal to 2, the j is equal to 1, and if we were hash it, we would expect it to be value 5 because that's just kind of what we did ahead of time to make sure we know what's going on. And so let's go through the math itself. So h is equal to I, in this case is 2, and the number of columns is 0, 1, that's 2. So that's 2. And then we would add j. J in this case is 1 plus 1. Ooh, my handwriting is horrible. But this turns out to be 5, which is what we expect. So now once we have this 5 inside our code or anything else, we want to be able to decode it back into ij. And so I is equal to h, which in this case is 5, divided by the number of columns, which is 2 once again. And this is equal to 2.5, but in computer science and integer division, we just round down, and so this is equal to 2, which is what we expect. For j, what we do is we take the encoded value 5, and we modulus it by 2, and so the remainder from 5 divided by 2 would equal 1, and that's the j that we expect. Really simple. This formula really works, and that's basically how it's done. So let's look at the code. The code we've got here, C++, but it's really simple, so you can translate this to any language. We've got two functions, encodePosition and decodeValue. EncodePosition takes a matrix, it takes an integer I and an integer j, it just gets the number of columns, and it does the math for us, and it returns an integer. Basically what we did before to get value h. decodePosition is going to take a matrix, it's going to take the encoded value, which is h, and it returns a pair of integers. Don't worry about the C++ syntax. It gets the number of columns, it does the math that we just did, and it returns the pair of integers I and j. So just to make sure that this code works, we've got our C++ driver code right here. We've got a vector of vectors, an array of arrays, and that is going to form my matrix. It is equal to the exact diagram that we have set up over here. The values are the same. We set up the I and j. If we access the matrix of 2, 1, then that would be value 7 if we print that. If we wanted to encode 2 and 1, we would call the function, and if we printed that, the encoded value would be equal to 5, which is what we expect. If we wanted to decode that encoded position, we would pass the encoded value in the matrix into the decodeValue function. It returns this pair. After getting the values out of the pair, we see that I is equal to 2 and j is equal to 1, which is exactly what we expect. And so if we wanted to come back full circle and access the matrix at index I for the row and index j for the column, that would also be 7, which is where we started out from. So this is a really simple trick. I really like it, and it's really important to know. So if you like this, please like this video, subscribe, leave a comment if you want to see something else. And I'm srcmake. Make sure you bookmark this page, and thanks for watching.